Hi everyone, so we're going to move on with simultaneous equations today, and we're going to look at the more difficult simultaneous equations on the higher tier paper, and these are grade 8 and 9 questions, so they're quite tricky questions and you need to follow this video step by step. You may need to pause it here and there, and I'd like you to make sure that you get this example and the next example in your notes, please, in full. Okay. So these sorts of questions tend to come at the end of the exam as well, and they're normally worth maybe 5 or 6 marks, so it's quite a big chunk of marks out of 100 just for this one question. Now, the way that we're going to solve these, it's not like our linear simultaneous equations where you'd maybe have x plus y equals 6 and then, I don't know, 3x minus 2y equals 7 that we did a couple of weeks ago. This is much more complicated. One of them is like our old simultaneous equations. It's linear, it's just got x's and y's in, but the other one is quadratic. It's got something squared and some letters multiplied by themselves in here. Now, sometimes when people look at this, one of the really common errors in the exam is that people go, well, hang on a minute, I just want squared in here, so why don't I just square both sides of this? But if I square both sides of this, it does definitely not give me x squared plus y squared equals 36. This side gives me 36, but here, the x plus y, if I'm squaring this, I'd have to square everything. So that means I would need to do x plus y all squared. Notice I'm doing this in red for danger. So x plus y all squared would be x plus y times x plus y. And then we'd need FOIL rule. So x squared plus xy plus another xy plus y squared. So that would give me x squared plus 2xy plus y squared on this left-hand side. And actually, okay, I've got my x squared and my y squared, but then I've got this 2xy that I can't do anything with, and it's got both of the unknowns in. So that actually is definitely not the way to go. So the method that we're going to use is called the method of elimination. And what we're going to do is we're going to use this easier linear equation to make one letter the subject of the equation, and then we're going to substitute that letter in to this other equation and hopefully end up with an equation, a quadratic equation that we can solve. And there's quite a lot of steps to this, so we do need to take our time with these questions. So let's get started. Okay. So first of all, I'm going to make one of these letters, either x or y, it doesn't matter which one, and sometimes in some questions it might be easier to get one letter on its own than the other, so you just choose. In this one, I'm just going to get y on its own, I'm just going to leave that y there, so I'm going to take the x over to the other side. Subtract, so I'm going to get rid of the x on that side, do the same on the other, so making y the subject of that linear equation is going to give me y equals 6 minus x, and I'm going to call that equation 1. And now what I'm going to do, I'm going to substitute in, so let's just write that in our notes, I'm going to substitute y from equation 1 into, and I'm going to call this quadratic equation, the more difficult one, equation 2. So I'm going to substitute that y into equation 2. So let's just have a think about that. So if we're looking at this y value, here, everywhere there's a y in this equation, I'm going to put that y value in. So 6 minus x, which is what y equals, is going to replace this y value in my equation 2. So let's do that. So x squared plus, and now instead of y, I'm going to put 6 minus x. The whole thing needs to be squared because the whole of y is squared. So 6 minus x squared, and that is equal to 20. And now what I've done, I've eliminated one of the unknowns. So both of these equations had an x and a y in them, and now this one's just got one letter, just got x in it, so I should hopefully be able to carry on and solve this. So that's the first step. That's actually the most difficult step. And now what we're going to do is we're going to use methods that we already know, things like FOIL rule and factorising a quadratic, to work down this and to solve this equation. Okay, so let's keep going. So let's simplify this. So 6 minus x all squared, so 6 minus x times by itself. So some FOIL rule to do here, some expanding, so let's leave that x squared there. 36 minus 6x minus 6x, minus times minus is a plus, so plus x squared is equal to 20. So now let's collect some like terms here, so x squareds, there's 2x squareds, minus 12x, plus 36 is equal to 20. And this now, hopefully, you definitely recognise as a quadratic equation. Now, to solve a quadratic equation, we have to have 0 on one side. It always has to be the quadratic equals 0 to solve that. So I'm going to move this 20, and I'm going to take 20 off both sides. So that's going to give me 2x squared minus 12x plus 16 equals 0. Now I could do my product sum here, but actually if I look at this, I can simplify this equation down, make the numbers a bit easier by dividing everything by 2. So that's what I'm going to do here. I'm going to divide by 2 all the way along this. And like I say, you don't have to do that, but I can see that all of these coefficients are even. So if I divide by 2, it's just going to make the numbers a bit simpler. So x squared minus 6x plus 8 is equal to 0. And now we've got a quadratic to solve here. Okay, so this is why we've been doing a little bit of work in the last couple of lessons to remind ourselves of factorising and solving quadratics. So looking at this, what's going to happen? I can always put a 1 in front of this x squared just to remind myself that that coefficient is 1. So the product is going to be the 1 times the 8, and they're both positive. So let me write that over here. So my product, where I'm multiplying, that's going to be positive 8. And my sum, where I need to add two values together, is going to be negative 6. So I'm looking for two numbers that when I multiply them give me positive 8. When I add them together, give me negative 6. Well, because this is positive, the signs must be the same. Plus times a plus gives a plus, or minus times a minus gives a plus. And because this is negative, when I'm adding them together, I can see that they're both going to have to be negative. I want a combination of factors of 8 that give me a sum of 6. And either, if you don't see it straight away, you can go through the factors of 8, so 1 and 8, 2 and 4 then, and actually 2 and 4 gives us this combination of negative 6 straight away. So what I'm going to use here, minus 4 and minus 2 as my factors. Minus 4 times minus 2 is plus 8. And then if I add minus 4 and minus 2, I'm going to get minus 6. So these are my factors in the middle. So now let's have a look at splitting this up. So I'm going to have my 1x squared, my minus 6x, I'm splitting up into minus 4x, minus 2x. Well, that definitely works. Minus 4x minus 2x is minus 6x, plus my 8 is 0. And then I'm going to factorise this by pairs. I think I'm going to run out of space here, so I'm just going to move onto another sheet of paper so that we can see what's happening. So this is where we're up to. Let's keep going with that. So x squared minus 4x minus 2x plus 8 equals 0. So I've just written that out from before. And now my factors, by grouping, I can look at this pair and this pair. Common factor here is x. And now I know that my second bracket here has got to be x minus 4 if this is going to work. What do I need in the middle? Minus, and then a 2 as a factor here. Let's just check that that works. Minus 2 times x is minus 2x. Minus 2 times minus 4 is plus 8. So this is definitely correct. So my factorised expression, x minus 4, x minus 2 is 0. So solving that, x minus 4 is 0. So adding 4, x is 4. Or x minus 2 is 0. So adding 2, x is equal to 2. Okay. Now I haven't finished this question yet. So x equals 4 and x equals 2. Because my original question had both x and y in it. So all I've done so far is found the x values. The next bit is a bit quicker than just finding the y values that correspond to them. So be careful again. A common error is people stop now. They say, right, I've done all this work. I've found my x values. I'm done. We're not. The final couple of marks is going to be for working out my y values as well. So how am I going to do that? I'm going to, let's just say what we're going to do. So we're going to now find corresponding, so I'm going to find the corresponding values of y. And to do that, what I'm going to do is I'm going to go back to my work in here. And I'm not going to substitute into this more difficult equation. I'm going to substitute into this simpler one. And actually, I'm going to use the one that I've rearranged because I've already taken the x away from this side and got y as the subject. So that's what I'm going to do. I'm going to substitute these x values into this equation. So substitute x values into equation 1. And I'm telling the examiner what I'm doing, so even if I make a mistake, I'm still going to get some method marks here because they can see what I'm trying to do. So equation 1 says y equals 6 minus x. So when x is 4, that's going to give me y is 6 minus 4, which is 2. And then when x is 2, that's going to give me y equals 6 minus 2, which is 4. So these ones are quite symmetrical. Sometimes that happens, sometimes it doesn't. The next equation that we work out and that we solve, the next simultaneous equations, you don't get nice answers like this that are so symmetrical. Okay, so let's just finish off by writing out our solution. So my solutions are x equals 4 gives y equals 2, or x equals 2 gives y equals 4. And there, my solutions to this simultaneous equation, and that gets me my 5 marks at the end of the exam. Okay, what I'd like you to do is to maybe rewatch that, maybe pause it here and there, but I want you to get that full example with all the method into your notes, please. And then what I'm going to do in the next video is do another equation where the starting point is maybe not quite as simple as this one, and we've got to do a little bit more rearranging to begin with.